What's up, Normie? I see that you haven't seen my last video because I can see how many times it's been viewed. So go and watch that. Alright, so I'm doing some more problems from that website that I gave you. I found a different practice exam though, and I'll be working on 7 problems from that test. Okay. I'm doing them on the chalkboard this time. Let's see. There. Okay, hopefully that works. So, alright, that's the highest I can go. Alright, the first problem is on scientific notation. And I'll try to write this big so you can read it. The radius of Earth's orbit is, let's see, billion, 150 billion meters. What is this number in scientific notation? Okay, so I think you should be able to read that. Okay, and then it gives you some options. A, B, C, and D. And the options are 1.5 times 10 to the negative 11, 1.5 times 10 to the 11th, 15 times 10 to the 10th, and 150 times 10 to the 9th. Okay, scientific notation. First of all, in college these answers would all be wrong because really you need meters. Because the question is in meters. If it was inches, you would put inches. If it was feet, you would put feet. If it was miles, you would put miles. Meters is N. But you don't have to worry about that right now. You're in high school, I guess. So, scientific notation, right away these two are wrong because it's 15 and 150. In scientific notation, you can only have one number in front of the decimal place. The decimal place is right there, decimal place is right there, decimal place for that one is right there, decimal place for that one is right there. So right away these two are wrong because that one has 3 digits in front of the decimal, this one has 2 digits in front of the decimal. So now we have to figure out which one of these two is the correct answer. Which one of these two is this number right here? So to put a number into scientific notation, let me write this number out first. So this is the hundreds, thousands, millions, billions. So this is 150 billion meters. That is the radius of the orbit of Earth. So, here's the sun, here's Earth. Earth moves around the sun, and the radius is the distance from the center of the sun to the center of the Earth. That distance is 150 billion meters. To put this number into scientific notation, we have to know where the decimal place is. In this case, it's right here at the very end, because you could put 0.000 as the same number. To write the number in scientific notation, we move the decimal place right next to the very first digit, and it has to be right there. It can't be over here. It has to be to the right of the very first digit. So, if we move it, how many spaces do we move it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We move the decimal place 11 times to reach right there. So, this number in scientific notation would be 1.5, because we move the decimal place right there. 11 times means we're going to have times 10 to the 11th. So the answer is that one. When we move the decimal place in that direction, we get a negative exponent. I'll save that for another example though. Okay, you should do this on a piece of paper. Alright, the next problem is on scientific notation also. Okay, this one actually includes a negative exponent. This is number 2. So number 2 simply says 3.6 times 10 to the second equals what? That's a question mark. Equals what? Well, let's see. Let's say we have, a number like this, 550. Okay? That's 550, and we want to write that in scientific notation. So the decimal place is right there. We move it immediately to the right of the very first digit, and it becomes 5.5 times 10 to the number here is going to be how many times we moved it. We moved it to the left 2 spaces, so that means it's going to be a positive 2. Oh, never mind, this one doesn't include negative exponents. Okay, so how could we go from this to that? Well, 5.5, if we move the decimal place 2 spaces this way, the decimal place is right there now. The empty space we have to fill it with a 0, 550. Okay, so that's how we go from there to there. So this answer should be fairly easy to get to then, because we have 3.6 times 10 to the second means we're going to move the decimal place 2 spaces this way to get our answer. So 3.6, move the decimal place 2 times right there. The empty spot is going to be at 0, so the answer is 360. And I forgot to write down the options, but the options are 3.600, 36, 360, D is 3,600. So the correct answer is C. Alright. Another example with scientific notation. Make sure to do this yourself. Write it out, practice it. Number 3. Which expression represents zero point zero 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 in scientific notation. So this is 0.000007. So that's 1, 2, 3, 4, 5, 6 zeros right there. Okay, which one of these options represents that number in scientific notation? The options are 7 times 10 to the negative 9, 7 times 10 to the negative 7, 7 times 10 to the 7, 7 times 10 to the 9th. Okay, so this number, let's write it out in scientific notation. Oh, that's 1, 2, 3, 4, 5, 6, 7. Alright, so earlier I said that to write a number in scientific notation, we had to move the decimal place to immediately to the right of the first digit over here. This time we're going to move it to the very right of the first digit over here. So let's see how many spaces we have to move. 1, 2, 3, 4, 5, 6, 7. And the decimal place goes right there. So the number will be written as 7 times 10 to, now what power is going to go up here? Well, how many times did we move it? 1, 2, 3, 4, 5, 6, 7 times. But this time we moved it to the right. That means it's going to be a negative 7. So the answer is B for that one. Alright. Okay. We're going to move on from scientific notation, and we're going to do a word problem. A word problem. So again, go to that website I told you about. It's www.cde. Can you read that? Yeah. .ca.gov. And then you can search for something. There's a place where you can search and just type in, CAHSEE. And then there will be something like practice problems or something like that. And you should do them. Alright, let me write this out. The 5 members of a band are getting new outfits So there's a band, it has 5 members, they're all getting new outfits. They're all getting the same outfit. Shirts cost $12. Pants cost $29 each. And this is $12 each also. And boots. Boots cost $49 a pair. And then the question is, what is the total cost of the new outfits for all of the members? And, okay, I hope you can read all that. Let's see, pair. Yeah, I think you can read all that. And the options are, that's an A, $90, $95, $450, or $500. So how much is it going to cost for the 5 members, like in total, to purchase this outfit that they need? Okay? There's 5 members. Each one needs a shirt that costs $12. Each one needs a pair of pants that cost $29. And each of them needs a pair of boots that costs $49. So, okay, there's 2 ways we could go about this. So, they're each going to have the same outfit. How much is one outfit going to cost? Well, one outfit is going to be $12 for the shirt, $29 for the pants, and $49 for the boots. So how much is that? Well, see, 2 plus 9 is 11, plus 9 is 20. So 0 and a 2, carry the 2. 2 plus 1 is 3, plus 2 is 5, plus 4 is 90. So for one person, the outfit is going to cost $90. There's 5 of them, 5 members, so 5 times 90, or let me write it like this actually. 5 members times $90, which I'm just writing it out with the things that there are 5 members times $90 gives you, well, okay, if you don't know how to do this, let's do it like this. 90 times 5. 5 times 0 is 0. 5 times 9 is 45. So the total cost is going to be $450, which is this option right here. Now, another thing to notice is that we've gotten the answer C more than once. This is the answer C. If you're ever stuck on a problem, just answer C. It's always going to be multiple choice. C is the most common answer that you can get. Alright, let's move on to fractions. Fractions. Alright, number 5 says this, 11 over 12 minus parentheses 1/3 plus 1/4 equals what? That's a question mark. That's a question mark. Okay. And the options are 1 over 3, 3/4, 5/6, Alright, well, let's figure out what this number gives us. Well, okay, you don't need to know this, but this is a way that you can think about it. In a fraction, like this one right here, whenever the top number is bigger than the bottom number, whenever the numerator is bigger than the denominator, that means that this fraction is greater than 1. It's greater than 1. If the numerator, like in this example, if the numerator is smaller than the denominator, then this number ends up being less than 1. Less than 1. Now, okay, how does that help us? Well, you don't need to know this right now, but this answer is not the correct answer because these two numbers are positive, so we're going to have a positive number in there. This number is smaller than 1 because the top one is smaller than the bottom one. This number is smaller than 1 minus a positive number will be a number smaller than 1 also. So it obviously can't be that one because that number is bigger than 1. So that's why we cross that one away. It can still be one of these three though. Let's figure out what that number is though. So to figure out this problem, you need to apply your order of operations, remember? PEMDAS. So parentheses go first. So parentheses, and in the parentheses we have 1/3 plus 1/4. What does that equal? Well, to figure that out, we need a common denominator. Common denominator just means we need to get the bottom numbers the same. And to do that, well, this is a special way to do that. So what is it called? The lowest common denominator, I think is what it's called. Basically, we need to find the smallest number that 3 and 4 are a factor of. So, for example, let's see what would be the smallest one. So 12. 12, yeah. 12 is divisible by 3 and it's divisible by 4. So is the number 24. 24 is divisible by 3 and it's divisible by 4. But the smallest one is 12. Really, you don't have to use the smallest one. It's just more practical because you have a lot less reducing to do at the very end. A surefire way to always get the common denominator is to just multiply. Okay, so the method to doing it is you multiply that number by that number, but you have to multiply it to this fraction on top and on the bottom. Over here, we're going to multiply the bottom number by 3 and the top number 2. Let's see what this gives us. This gives us, let's see, when you multiply fractions like that, you multiply the top numbers. So this fraction, or this part, becomes this part right here. 1 times 4 is 4, 3 times 4 is 12, plus, and then this part right here becomes this part right here. 1 times 3 is 3, 4 times 3 is 12. So you see now we have a common denominator, 12 and 12. So when two fractions have the same common denominator, it's easier to add them. Well, you just add the top numbers. 4 plus 3 is 7, and then the denominator stays the same, 7 over 12. So 7 over 12 is what is here inside of the parentheses. So let me erase some things. Hopefully you're writing this down. So this problem becomes 11 over 12 minus, and then in parentheses, we figured out that was 7 over 12. So 7 over 12. And now you see that these have the same denominator, 12 and 12. So the problem becomes easy. We just do 11 minus 7, and whatever that is over 12. Another way we can write that is just 11 minus 7 over 12. And then 11 minus 7 is just 4 over 12. You just subtract the two top numbers because they have the same denominator. The denominator stays the same, 4 over 12. Now, 4 over 12 is not in any of these options here. That's because we need to reduce that. Now, how do we reduce this? Well, let's see. Both the numerator and the denominator are divisible by 4. That means we can reduce the fraction by, there's a lot of different ways that you can learn this, but this is one of the ways. This is just my way. Divide the top number by 4, divide the bottom number by 4, because 4 is the greatest common factor for 4 and 12. The more you do this, the more you'll understand what numbers to divide by. So 4 divided by 4 is just 1. 12 divided by 4 is 3. So the answer is A, 1/3. Okay. Alright, next problem has to do with negative numbers. Alright, which of the following numerical expressions results in a negative number? And the numerical expressions that they give you are, let's see, -7 plus -3, -3 plus 7, and then I'm going to write the other ones out over here. Okay, so which one of these evaluates or results in a negative number? Okay, don't be intimidated by the parentheses. They don't really mean anything. All this means is -7 plus -3. Well, if you have two negative numbers and you're adding them, you just add them like normal numbers, and then the answer is negative. So -7 plus -3, all that is -10. So you can imagine that as negative, you owe somebody $7, and then you owe that person more money, so minus another 3. So you end up owing that person that much money, $10. Okay? So this one over here, -3 plus 7. So all that is, we can erase the parentheses and it's the same thing. -3 plus 7, let's say you owe somebody $3. And then you pay off $7. So how much do you end up owing them? Well, that results in, not negative, just +4. +4. Well, okay, you owe that person $3, you give them 7, so now they owe you 4. And this one it can be like, you owe that person $7, and now you owe them $3 more. How much do you end up owing them? $10. Okay. Alright, the last one's over here. Let's see. So again, we can erase the parentheses. They don't mean anything. You only really have to worry about them when there's either a negative sign in front of them, but this is positive in all of them, so we don't have to worry about that. 3 plus 7, that should be very easy. 10. The answer, by the way, was this first one, because that's the only one that's going to result in a negative number. Negative. This one was positive, this one was positive. We're going to see that that one is also negative. Huh. Oh, that's weird. Alright, whatever. Oh, no, I forgot to write down one of the parts to this one. This one is plus 11. Alright, so there should be an 11 in there. Again, we can erase the parentheses, not worry about them. Okay, so let's say somebody owes you $3, and then you owe that person $7. So really 3 plus negative 7, that becomes a negative 4. And then we have the plus 11 still. So you owe that person $4, and then you give them 11. So how much do they owe you to break even? Well, that's just going to be 7. Another way you can think of this problem right here is just by rewriting it. We could say 11, we could say positive 11, that's that positive right there, positive 11 minus 4 equals, well, positive 11 minus 4 is obviously 7. So the only one that came out negative was that, right there, negative 10. Alright, last problem. And then I go home, because it's late and I'm tired. Okay, last problem. So, number 7. So, 100 is multiplied by a number between 0 and 1. The answer has to be and then it gives you these options here. Let's see, we have A, which is less than 0. Another way of saying that is negative, because if anything is less than 0, it's negative. The second option says between 0 and 50, but not 25. Alright, the other options are C, which says between 0 and 100, but not 50. And then D says between 0 and 100. Alright, can you read that? No. Okay, so it would be multiply a number. Okay, so 100, the number 100 is multiplied by a number, and this number has to be between 0 and 1. Okay, so what numbers are between 0 and 1? Let's see, here's 0 on the number line. say the number line right there. See that? Yeah. And then over here we would have like, let's see, -1. This would be -0.5, and so on. Over here we would have, let's say 1 is like way out here. 1, it's right there. Halfway in between is 1/2, or 0.5. Think of this as like $0, $1. Right in the middle you would have 50 cents, 0.5, 0.50. We could also write that, 0.50. So this number would be between 0 and 1. We could also have like, right there would be a 0.25. Right here would be a 0.75. And any numbers in between. 0.3, 0.4, 0.8, 0.11111, anything like that. Okay? So if 100 is multiplied by a number between 0 and 1, a number right here somewhere, the answer has to be, okay, let's think about this. If 100 is multiplied by 0, that is 0. Let's see where I can write that. Alright, I hope you have all this written down, because I'm going to erase it. Just pause the video, rewind it, write it all down, so you can have it. If 100 is multiplied by 0, well, anything multiplied by 0 is 0. If 100 is multiplied by 1, well, anything times 1 is itself, so 100 times 1 is just 100. Okay, so the smallest the number can be is 0, the biggest the number can be is 100. So let's see, that takes away that option only, because this one says between 0 and 50, but not 25. Let's pick a number in between. Let's say we have 0.25. If we do 100 times 0.25, I'm not going to do that for you, but if you do that, the answer becomes 25. And when I think about it with scientific notation. Think about it like this. If you have 100 quarters, that's $25. Okay? So obviously, the answer could be 25. So again, that answer is obviously not the right one, because this one says, but not 25. But it can be 25 if it's between 0 and 1. Let's prove this one wrong. This one's going to be wrong too. Between 0 and 100, but not 50. It can be 50, because if we do 100 times 0.50, if you have 100 of 50 cents or whatever, that becomes $50. 50. So this answer is wrong also, because that one says but not 50, but it can be between 50. So this answer is not the right one, because this says that the answer is going to be negative. And there is no number in here that you can multiply 100 by that will give you a negative number. That's wrong. This is the correct answer, because if you multiply 100 by any number in between 0 and 1, it'll be between 0 and 100, because 0 times 100 is 0, so there's that. 100 times 1 gives you the 100, so there's that. And then anything in between will be based upon what number you multiply by. You see 25 is in there, 50 is in there, 80, 90, 72, all those numbers are going to be in there, depending on what number you multiply by. Okay, I'm trying to help you to pass your CAHSEE. Go and watch these videos. I'll make another one tomorrow, maybe.